Okay, so to start with the question then, we're looking at the topic science, God, resurrection. So there's a period after science, a period after God, and question mark with resurrection. But I find that the question begins with the very first word, science. Do we actually know what science is? And I say this both tongue-in-cheek, but also a little bit more deeper on the philosophical plane. As I was going through medical school, I remember we had classes on ethics longitudinally throughout the 4 years that I was in medical school. And we would discuss such questions as, can we put a price tag on life? Because the reality is, we have a certain number of dollars that we can spend in healthcare and a certain number of people to whom we can appropriate those dollars. How much money do we give to every person? Or in what condition do we give it to them? 90% of the money spent on healthcare in the United States is spent on the last 18 months of a person's life. Would it be ethical to say this person probably has less than 18 months to live? Let's not fund them so we can fund 9 times more other people in their efforts and endeavors to live. Is that an ethical approach? And the fact of the matter that I discovered as I was in medical school was people had no basis off which to even begin answering those questions. Because those people who were studying medicine often had not studied ethics, had not studied philosophy, let alone the philosophy of science. There was just this underlying assumption that science was somehow the mode of receiving all truth in the world. That basically, if you could not understand it by science, it was not worth understanding. And then when they were approached with questions like these, ethical questions, they had no basis off which to even begin to answer them. And quite frankly, I would say that I would fall into that category as well, were it not for the fact that I had to interact with others who pushed me to understand the bases of this question. So Samir Okasha, who's a professor at York University, has said this, quote, "Something quite like science worship is a genuine feature of the intellectual landscape." And this is what has given rise to the new atheism that we see in the academic circles around us. Also at Oxford University, I frequently saw Richard Dawkins biking down the street with his helmet. It was rather cute, I would say, just him on his little bike biking down the street. Like, oh, that's Richard Dawkins. His area of science, and also Daniel Dennett and Sam Harris, etc., the new atheists, tend to capitalize on the notion that no knowledge is true knowledge apart from scientific knowledge. But is that necessarily true? And I would argue that it's obvious that is not true. For the vast majority of us who saw the recent comments about the Holocaust in the news recently, the Holocaust centers and all that, I'm not going to go into the politics of that all, we would all agree that the Holocaust was abhorrent, was perhaps one of the worst events in all of human history, plumbing the depths of human depravity. But none of those statements can we affirm or assert from a scientific perspective. Absolutely none. You can't use science to say the Holocaust was wrong. In fact, it was science that people were using within the Nazi legislation to argue that the Holocaust was right. Science based on the eugenics movement, saying that in order for humanity to advance, we need to weed out weaker members of society. Who are weaker members of society? The Jews were argued as some of those. And of course, the Holocaust wasn't just directed at Jews, but tremendously so. And Jews were singled out as people who showed the weakness of mankind, as opposed to, of course, the Aryan race, which is the stronger form of mankind. So let's weed out the weak in order to advance the strong. Because the enterprise of mankind is to survive, to evolve. Therefore, let's weed out the weak for the sake of the strong. A very quick and crude generalization, of course, of the eugenics movement. I apologize for having to make it so short, but that is at least how the Nazis saw the eugenics movement, and they were using that information in order to capitalize and to defend the Holocaust. You cannot use science to answer questions of ethics. And yet, we see people saying that the only knowledge worth having is the knowledge based on science. No, science has its limitations. But unfortunately, because of this prevailing understanding, as Professor Okasha says, that science is almost worthy of being worshipped in the intellectual arena, people don't answer the questions specifically about the extents and limitations of science. What is science? How do we even define what science is? Philosophers of science have tremendous difficulty answering that question. So What is science? I pose the question to you tonight. And generally speaking, people might try to categorize things, and they'll say, well, biology is science, and physics is science, and astronomy is science. And I would say, yes, those are instances of science, but what is science? What is the principle that binds all of these individual fields of study together? And you'll also have people who would argue for certain forms of science that others would not, such as social sciences. Is anthropology a science? Anthropologists would want to say yes. Whereas people in the hard scientists would say no. Cognitive sciences, are those hard sciences? You have people who disagree on that. History, the historical study of the past. You're trying to explain data using models to the best explanation, inference to best explanation. Exactly what science does, but is history a scientific enterprise? Most people would say no. So how can we define what science is? It's extremely difficult when we start getting down to it. Are we going to say that science is an attempt to understand the world? Well, so is religion. Religion is an attempt to understand the world. So are the arts. So is poetry. So the arts are trying to do the exact same thing, but no one would argue, generally speaking, that the arts are a science. Is it a particular method of investigating the world? Is science that which involves experimentation? Most people would say yes, but there are fields of accepted science, such as astronomy, that are not experimental, they are observational. And so can we hang our hats on the experimental nature of sciences, of hard sciences? No, we cannot. What about, trying to go a little bit deeper, science is a construction of truth based only on observed data and proved models of explanation. You're trying to drill a little bit more in there, and we're saying it's a construction of truth based only on observed data and proved models of explanation. Unfortunately, that doesn't even work. The definition of observation, and we know observation is critical to science, but the definition of observation is even a difficult one within the bounds of science. So for example, can using an instrument be a part of observation? So if I drop a ball off the Leaning Tower of Pisa to see if it falls at the same rate as a lighter ball, of course Galileo is the one who argued that mass doesn't determine the effect of gravity on an object. Is that actually, or weight, sorry, doesn't determine. Is that actually something that I'm observing? And we would all answer yes. A ball, if you're watching a ball fall off the Leaning Tower of Pisa, that's observation. Now, what if I watch the ball through a telescope? Am I still observing it, or is the instrumentalism that's working as an intermediary, meaning I'm not actually observing it? Well, most people would argue you are still observing it if you're looking through a telescope, and that's fine. But what about when it comes to atoms? We know atoms exist, but no one has ever seen an atom. Now, we use electrons microscopes to see what approximates an atomic cloud, but is that really what observing an atom at that point? We're reconstructing an image digitally in order to understand what might be there. Is that observation in and of itself? The first scatter plots of molecules that were the basis of quantum theory never actually observed it. But we believe in quantum theory, and quantum theory has provided us with lasers. And lasers we can understand and see that they actually work, and we can see the power of guided missiles, and we can understand our DVD players work. And so we say, well, the results of these observations still work, therefore we're observing. But are we? No one's actually ever seen the electrons change in energy in that way, or have they? So the question of observation is a very difficult one to grasp. But I would also even argue that, and let's go back to our working question here, proven models of explanation. The word proof, historically speaking, means deductive reasoning, and we're going to come back to this in just a moment. But the vast majority of science is not done with deductive reasoning, it's done with inductive reasoning. So can we say that we're actually proving anything when we use inductive reasoning instead of deductive reasoning? We're going to come back to this in just a moment. But all this to say, it's not at all easy to demarcate science. What is science? Not at all easy to answer, and philosophers of science have been very familiar with that for a long time, the problem involved in demarcating what science is. So that's a place to start with. Now, what I want to emphasize is that science is, at the very least, an attempt to corral our avenues of receiving knowledge and to strengthen them. So, in other words, there are ways we receive knowledge. There are ways we build up our knowledge base. Science is an attempt to establish and strengthen those ways. I want to give you 4 ways tonight that we strive for knowledge. The primary one is through our senses, and we all understand this. So senses we use to gain knowledge. Science attempts to intensify the use of our senses. So for example, if we look and see something, great. How about we use a telescope to see further away? How about we use a microscope to see at a smaller level? Science is using instruments to determine and to intensify our senses. Okay? Avenue number 2 is testimony. To understand the results that others have come up with in their investigation and to incorporate that into our own knowledge base. In other words, when somebody tells you something, you're gaining knowledge through their testimony. Science attempts to intensify this, primarily through avenues such as publishing. So people have published their results in experimentation. That's their testimony to what they have discovered, scientifically speaking. And so science capitalizes and intensifies the route of testimony. A third avenue of gaining knowledge is through rationalized thought, careful, reasoned thought. So if we deduce something by our thought, then we can come up to a new item of knowledge. Science intensifies that by peer-reviewed journals, specifically on methodology. As we're thinking about an experiment and as we're planning it out, we publish the methodology of that experiment so that others can see, was our reasoning correct or incorrect? And I know many of us, as we study journal articles, skip the methodology section. That is an expedient. Let's not do that if at all possible, because methodology is often where science is flawed. And so we need to understand whether the reasoning used is good reasoning. Science intensifies that through a peer review of methodology. Finally, memory. By our memory, we have access to knowledge. Science intensifies this through the annals of publications, through years and years and years of publication. So if you want, you can go back and read what Isaac Newton wrote in the 17th century. And I have to say, with a measure of pride, that Isaac Newton was at my college in Oxford, Christ Church College. Just going to drop that out there. But memory is also a component. So senses, testimony, thought, and memory, the 4 avenues through which we receive knowledge, are intensified by science. That's what science is attempting to do, is to intensify and make more reliable our normal avenues of receiving knowledge. So it's not something magical, it's not something separate, it's not something so different and disparate from our normal avenues of receiving knowledge that it can be considered on a pedestal of its own. Scientism, which we'll be talking about in a moment, tries to dichotomize science from all other avenues of receiving knowledge, but it's not that different. It's just an intensified and an attempt to defend that knowledge that we attain through normal avenues. But out of these ways of intensifying our knowledge acquisition come some of the bases of the scientific method, and 2 in particular that I want to discuss today are testable hypotheses and reproducible results. In order to be actually following the scientific method, especially in the experimental realms of scientific inquiry, you need to have a testable hypothesis and you need to have reproducible results. So within the chemistry lab, you're going to try to test your hypothesis, and the results need to be able to be reproduced, not just by you, but by other people who studied it as well. Given these parameters, now I want us to understand, the moment you add parameters, they might be good parameters, but the moment you add parameters to a method, you are limiting what that method is useful for. All of a sudden, you can't answer certain questions. In this case, there has to be something that's reproducible in a lab. In a lab, that means it has to have a closed system. You can't have an open system, otherwise the results might not be reproducible. So you have to have a closed system. The questions about God in the universe automatically imply an open system. If you're talking about the universe itself, apart from God, you have a closed system. But the moment you ask the question about the creator of the universe, you have something outside the system that you're taking into account. Science has difficulty answering that because it's no longer falling within the parameters in which science investigates. Are you with me so far? That was a lackadaisical nod, but I'll go with it. I will take it. So the questions that science then engages in are of a limited kind, and we're going to come back to this in just a moment. Let's move on to the next topic, science and faith. Now that we have attempted to define what science is more accurately, we've actually discussed some of the problems with defining science. let's move to this dichotomy between science and faith. Oftentimes, people assume, when they're looking at science and faith, that science is something that is well understood, well grasped, and is the pedestal, the apex of knowledge. And faith is something that you believe when you have no reason to believe it. That's often how faith is caricatured. Whereas in reality, we've just discussed how science is not this immovable, obvious object that we use. It's a little bit more fuzzy than that. And faith, well, faith is actually a part of science. And what do I mean by this? All right, let's look at the different ways faith are often defined. Now, the new atheists tend to define faith as something that you have no reason in and of itself to believe. You just believe it. Generally on authority, you take information that's given to you and you believe it. So for example, I believe what the Bible says. Why do you believe what the Bible says? Because the Bible says it and I have made the Bible my authority. The new atheists would characterize this as a form of faith, as the primary form of faith. A secondary definition, so let's call that first definition of faith blind faith. A secondary approach to faith I would call inference based on evidence. In other words, you have a body of evidence that leads you to conclude that there's a likely or probable understanding of something else. And because of the body of evidence you have, you can conclude on inductively usually, on something else. So for example, I just flew back from Malaysia a few days ago. I just got back in on Friday. When I got on the plane, I can guarantee you, I did not examine the plane. I did not check out the wings to see if there was structural integrity. I did not check out the landing gear to see if it worked. I didn't go to the pilot and do a breathalyzer test to see if he was sober. None of those things did I do. But I believed that plane would get me back to the United States. I had enough faith in the airline that the airline was doing those things, that I could just blithely walk onto the plane and stake my life on the fact that I will be coming back. Interestingly, it was Malaysian Airlines, so I'm not sure if I should have. Too soon? Probably shouldn't have said that. All the same, I trusted Malaysian Airlines well enough that I believed they had done the background work. Now, is that foolish? Is it foolish to walk onto a plane where you have tested none of the gear itself, none of the pilots themselves, none of the protocol? You don't even know what it is, yet you walk onto that plane. Why? Because the vast majority of planes that take off, come back, and do not crash, do not go missing, the vast majority do not. And so you're staking your life on the faith that you have in that airline. Is that foolish? And I would answer, obviously not. That's how we work almost all of our decisions in life. When you get onto the highway, you know that there have been accidents on the highway. You know that people die. In fact, more people die in vehicle collisions than do in airplane accidents. Yet, we get on the highway anyway, believing we're going to make it to where we want to go. This is faith. Truly, it is faith based on the experiences that we've had. You have no inherent reason to believe that that specific trip will work out. It hasn't happened yet. On the scientific level, even the fact that the sun is going to rise the next day cannot be scientifically proven. You can believe that it's going to happen because every previous day the sun has risen. You can believe because of the laws of physics that they will continue to work the way they have always worked, but you have no inherent reason to believe that apart from inductive reasoning. And the very notion of all of science is deductive reasoning, is proof, is flawed. The vast majority of science is not deductive reasoning. So, when I get on an airplane, I have good reason to have faith in that airplane company. To make it a little bit more personal, when we're deciding who to marry, we will say that I have a faithful wife or I have a faithful husband. Now, my wife isn't in the room right now. I have no idea what she's doing. No clue. But I have faith in her. Why? Because I know her character. I've seen her character. I've seen her for years and years. I understand what she's like, and given that I know what she's like in personal context, I can have faith in who she is. And it's not a poor assumption to have that faith. And so we operate in terms of faith on our daily life. We choose the most important person to walk through life with based on faith in who they are, who their character is. Now, let's turn back to science. Do we use blind faith when it comes to science? And the answer is yes. The vast majority of us and our scientific knowledge, even if you are a scientist, the vast majority of knowledge that you have in science was gained simply by trusting authorities in the field of science. Most of us believe in the planets in the solar system. Pluto is kind of an issue. We'll leave Pluto out of it. But the rest of the planets, we believe that they're planets. Most of us have not looked through a telescope to see those planets. We've had no evidence of our own. We believe the scientists and the astronomers who say that they're there based on their authority, based on the consensus of the people around us. But we just have blind faith in those people. So blind faith, especially when we're growing up as children learning these things, when you were learning about the solar system as a child, you didn't even rationally think, okay, well, these people have reputations that are on the line, therefore they wouldn't lie. You didn't think any of that. They just said, there's 9 planets. And you're like, okay, there's 9 planets. That's how we gain most of our knowledge. Most of us have not seen an atom. Most of us have not determined for ourselves biochemical pathways. Dr. Tour, of course, you're the exception, along with others studying under him, but most of us haven't seen it for ourselves. And yet in medical school, I sat down and memorized pathway after pathway after pathway in order to understand the processes of medicine and human physiology. But we haven't seen it for ourselves. We're just believing it on blind faith. I don't even know the guys who wrote the textbook, and yet I believed them. And that's how we approach science for the most part. So blind faith is a large part of our scientific base of knowledge. But more importantly, I would say inference based on evidence, that form of faith is also a large part of science. What do I mean by this? Let's talk about inductive reasoning. Every case of sickle cell anemia that's been studied at the genetic level has been determined to be present due to a single point mutation. Okay, a single point mutation leads to sickle cell anemia in every case that's been studied. You can use deductive reasoning if you're limiting your scope to just those cases that have been studied. Every case that's been studied of sickle cell anemia has shown a single point mutation. Does sickle cell anemia, in the cases studied, is it correlated to a single point mutation? Deductively, yes. Conclusion, done. Proof. But when we go from what we've investigated to all the other cases of sickle cell anemia that we haven't investigated, and we say, because this limited scope in 100% of the cases showed a single point mutation causing sickle cell anemia, therefore, all the other cases that we haven't investigated can be concluded to be the cause of the same mutation. That is inductive reasoning, and you cannot prove it. And yet all of science, not all of science, but the vast majority of science is built on that kind of reasoning. You assume that all of sickle cell anemia is functioning the same way as the cases you studied. But that's not proof. That's inductive reasoning, i.e. faith, as it's defined by the primary definition of faith, I believe. Same thing with Down syndrome. You've got trisomy 21. On the 21st chromosome, you have a triplicate instead of a duplicate. In just the cases we've studied, can we be sure of that? But we impute that to all the cases, and we do so rightly. I'm not saying that's wrong, but that is an exercise of inductive reasoning. That is an exercise of faith. And it's fine. There's nothing wrong with that. But to dichotomize science and faith is extremely problematic. For those of you who will go on to medical school or pharmacy school and study pharmacology, we prescribe tons of medicines that we know are not going to work for a certain portion of the population, because medication only works for some people, and if it works for enough people, we then prescribe it to all people. But we know it's not necessarily going to work, and yet we prescribe it anyway because it's the best way to approach the population dynamics. That's fine, but we're doing so based on less than deductive reasoning. And so when people approach science to say this is a specialized form of knowledge that goes above and beyond any type of faith is simply incorrect. The people who are saying that have generally not studied the philosophy of science or the way science works. Which leads me to scientism. Now, for those of you who want a definition of scientism, it usually is a pejorative term that's used by philosophers, but it is a real issue. When people believe that science is the only way to acquire knowledge, they have made a tremendous mistake. Science has its limitations. Like I said earlier, you need to have something with a testable hypothesis and reproducible results for most forms of the hard sciences to count. But most of what we know is not reproducible or testable. So for example, if I find a cake sitting on my table, as I did yesterday, my wife threw a surprise birthday party for me. If I find a cake saying, "I love you," written on a table, I can tell you the exact processes by which that cake was baked. I can tell you about flour, I can tell you about the water, I can tell you about the heat, I can tell you about the frosting and how it works chemically, and the sugars and how they break down. I can tell you about all that. But I cannot use science to tell you that my wife actually loves me. Science will not give me that answer. Also, there are certain questions, and this was posed pretty well by Rhodes, who was the president of Cornell University from 1977 to 1995. He gave a fascinating example. He said, if you ask the question, why is that kettle of water boiling? We can answer it by saying, well, there's a fire underneath the kettle that's causing energy to be transferred to the water. The water is undergoing a phase change. That phase change then causes the steam to come out of the kettle and to make this whistling sound, and we know the kettle is boiling. You can answer the question that way, or you can say, I wanted a cup of tea. You can answer the question both ways, and here's what Rhodes says. These are different answers, but both are true. Both are complementary and not competitive. One is appropriate within a particular frame of reference, the other within another frame of reference. There is a sense in which each is incomplete without the other. One is a scientific answer, and one is an answer about personal agency. You need really to have both in order to understand the reality of the question. So, I posit that science invites supplementation. It has its own limits, it has its own extents, it is extremely useful, but it invites supplementation because it can only answer certain kinds of questions. And the other questions, honestly, are the ones that drive us a lot more.